Hey everybody, welcome to the first day of notes. Sorry I couldn't be there to actually teach you guys this. Probably somewhere, with the rehearsal dinner, getting something done. So this is going to be a little different, but we're going to go through the notes. And if you have any questions, feel free to email me. I'll get back to you probably as soon as I can. Definitely be Monday office hours if you have any questions. We can do that too. All right. So we're going to go ahead and start the notes. What I would do is I would go and print them out if you want to, or if you can just write on the screen. I know you can use OneNote. Could even copy down the notes. It's up to you. All right. So today our topic is functions and inverses. Okay. So functions and inverses. What we're going to do. All right. Your success criteria is if you can determine whether a relation is a function by looking at the table, mapping diagram, a set of ordered pairs, or a graph. Okay. So, how can you determine if a relationship or a relation is a function? It's pretty easy. Well, the very first thing is we can find out every x value corresponds to exactly one y value. Okay, one x value corresponds to every one y value. All right, so the next thing we can say is each value of the domain. Let's keep the x's. Domain only goes with exactly one value in the range. The idea behind a function is it's predictable. Okay, we can predict it. Predictable. We know what's coming next. Okay? All right, so let's go a little thinner with this. Okay, so it's predictable. So remember, x value is domain. So if you're wondering, x value, when we talk about x value, that's the domain. When we talk about y values, those are our ranges. Okay? All right. Let's look at the next problem. So the reason. Okay, so we have a function. All right, this is what we call a mapping diagram. So it says Elvis's birthday is on January 8th, so is Colleen's. Kaylee's is on March 15th, and Marissa's is on September 17th. All right, this is a function, and the reason this is a function is because each x value corresponds to exactly one y value. This is the x value in this case, and this is the y value. So every person has only one birthday. So every person has one birthday. Just thinner too. Let's go with that. All right. Now, the reason this is not a function here? Okay. So you have 20 hours. Think of this as your x, and this is your y. 20 hours goes to 200 and 300. So, whoops, sorry. One input has multiple outputs, right? One input. The reason this isn't a function is one input has multiple outputs. So remember, one x value corresponds to one y value. Okay, now the one thing to notice here, okay, so these two x values had the same y value in common. But remember, the x value has two y values in common. So remember, so if I plug in 3, I can't get an output of 4 and 5. All right, but if I input 5 and 3, I could get an input or an output of something else. Okay, so remember, one input has one output. This one has two outputs. That's why it's not a function. All right, let's go down a little bit. All right, so is this one a function? All right, so if I input 15, output negative 20. Okay, so I input 20, output 7, input negative 19, output 11, input 5, output 19. Remember, these are your x values on the left, your y values on the right. Do they have, is there a different output for the same input? So are any of these the same? If any of these are the same and they have a different output, then you know it's not. But see every x value here, so every x value goes to exactly one y value. Okay, so this is a function. On the right here, so we have an input of 20. Whoa, don't want to do that. Input of 20, output of 1. Input of 10, output of 16. Input of 14, output of 15. Input of 20, output of 10. Yikes. We have an input, same input, different output. Okay, think of like some of you guys like to play video games, right? If I push the X button on my controller and it did something different every time, that wouldn't be good, right? That's what this is. Think of it as pushing that button on your your keyboard. What if I push the P button and P came out sometimes and L came out the other time? That would be weird. That doesn't work. That's why it's not a function. Okay, so X value. So we can say that the X value of 20 goes to different y values, goes to two different y values. All right, give me a second. Flip my monitor here. Hopefully this doesn't mess up anything. Okay. All right, now the reason for the next one. Okay, let's look at this one. X and Y. All right, input, all different inputs, all different outputs. Okay, every X value goes to exactly one Y value. So every X value goes to a different Y value. Now this one, okay, so we got an input 8 goes to negative 14. 10, 1, 5, 9, 20, 11, 10, 3. Well, our problem is this input, these two right here. Remember, same input, different output. That's not good. So X value of 10 goes to two different outputs. Of 1 and 3. All right, next one. All right, so input of 1 goes to 0, input of 4 goes to 1, 13 goes to 20. So again, same thing as up here. Every X value has a Y value. And if I'm writing too quick for you guys, go ahead and pause it. It's okay. You can do it. Here, how about this one? Well, 4 goes to 14 and 10. All right, so the X value, 4, has two different outputs, which are 14 and 0. So that is no bueno. Okay, so another thing that we have a function here. So we can look at actually on these next ones. So if we list each one of these points, so this one is what? 1, 5, 2, 1. This is 3, 1. This is 4, 1. And this is 5, 2. All right, 1, 5, 4, 1, 5, 2, 2, 1, 3, 1. All right, so they have all different inputs, 1, 2, 3, 4, 5. Okay, and outputs are some of them are the same, but some of them are different. But that's fine, because every x value has one y value. Okay? Now here we have what? 1, 2, right? 1, 2. What's this one? 2, 3. 2, 3. We have one right here. 3, 2. And then we have 3, 5. And the last one, 5, 4. Well, 1, 2, 2 to 3, 3 to 2, 3. So now we have one input with two different outputs, 2 and 5. So x value 3 has two different outputs. Two and 5. Okay? Now we're going to show something different down here that might help you out with that if it's a graph. But so we need to think back for this section. Actually move forward for this. We're going to skip this for right now. You're going to do this probably as a... Actually, let's look at it. Okay, so a relation is a set of ordered pairs represented mostly as these three things, right? Right there. Okay. Now, where did I go? Okay, so you have ordered pairs, table, graph, and mapping diagram. So those are the four things you're going to look at. Okay, four things we're going to look at when you're looking at a function. Different things. So remember, the domain is the set of the input values, which is the x values. The range is the output values, the y values. Okay, now if we're going to look at this and we're going to name the domain and range, okay, we can say that the domain here is 2, 2, 12, and 16. And I'm going to put them in a little bracket, curly brace, like that. And then the output, 14, 17, 8, and 15. That's my range. All the y values. Is this a function? Well, x and y, x has two inputs, 2 that have an output of 14 and 17. So no, not a function. And you can explain that. So input of x has two outputs, 14 and 17. All right. So let's go ahead down to this one, the vertical line test. This is like how we did up here. All right, the vertical line test, we can go back here. And so the vertical line test says if I draw a straight line anywhere on the graph, a vertical line, and it goes through 2 points, that means that that graph isn't a function. So like here, if I did it, since this goes through this point, doesn't go through any other points, this one only goes through 1 point, 1 point, 1 point, 1 point. Now this one goes through 1 point. This one goes through 1 point. If I draw a vertical line here, it went through 2 points. So that's why it's not a function. So we have what we call the vertical line test, which says a relation is a function if and only if the graph does not intersect the vertical line at more than 1 point. So like here, boom, boom, boom. Anywhere I draw this, it's only going to intersect at 1 point. Here, 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 and here. Same with this one. Boom, boom. Now here, I can go straight down. Sorry, it's curvy. It's hitting this point, but this, since it's an open dot, that means there's not a point there. So anywhere we draw a vertical line, nothing happens. All right, same with this. Here, I draw the vertical line. It hits at 2 points, right here and right here. So this is not a function. Same with this one. Anywhere I draw it, boom, 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 whole bunch of places, not a function. So these are not functions. All right, so let's move on. All right, so we are actually at 15 minutes now. It's probably getting a lengthy recording. So I'm going to stop here, and we are going to part 2. If you want to take a pause and wait, that is cool. All right, so the next part, the inverses section. This one's all about inverses right there, inverses. All right, So the success criteria for this says I can determine if a function has an inverse function, and I can graph the inverse function of a function as a reflection over the line y equals x. So when do you use the vertical line test? When do you use the horizontal line test? That's what you want to know here. Okay, so with an inverse, the domain and range are switched. We're going to switch them up for an inverse. That means the x becomes the y becomes the x, like Missy Elliott. Put your gain down, flip it, and reverse it. All right, so this one goes here, and then the y becomes the x value. So they are just interchanged. Okay, the x and y values are interchanged. Graphically, the inverse and original functions are reflections, like in a mirror, reflections over the line y equals x. All right, in the line y equals x, I'm going to do a Picasso-esque drawing over here so you guys know. Look at this. This is just perfect art right here. Now, this is a dotted line. This is the y equals x line. It's like that. So it's going to be reflection over this line. All right, so like, hey, the smiley face right here. You know, it's going to be reflected kind of like that over that line. It's going to be something that looks like that. Again, not completely graphically accurate there, but it's a start. All right, so if we're switching them, inverses, remember, we're just flipping it. So 17 and 5 becomes 5 and 17. 0 and negative 4 becomes negative 4 and 0. 12 and 3 becomes 3 and 12. Okay? The next one, let's just write 8, negative 20, and 9. Okay, and then we can do 19 to 5. Well, the 8 corresponded to the 2. The 2 corresponded to the 19 corresponded to the negative 20, so negative 20 to 19, and 9 to 5. Okay, so we're just flipping them. So let's look at the next ones. Boom, boom. All right, name 3 coordinate points from the graph shown. All right, so what do we got? Ones that go like right through the point. So let's see what we got here. We got one right. That looks like one. Whoop, right there. That would be what, negative 4, 0? Negative 4, 0. What about the vertex down here? It's what, negative 3, negative 1? And what else we got? This goes through a point exactly. So negative 1, 3. All right, now the inverse. What are the inverses? Well, we just flip them. 0, negative 4. Put them in parentheses too. Sorry about that. All right, negative 1, negative 3. And the last one, what, 3, negative 1. Okay, let's plot those. Let's use a different color. So 0, negative 4. So 0, negative 4. Negative 1, negative 3. So we got, go down, left 1, down, boom, boom, boom. And then 3, negative 1. All right, so what we do now is we have a graph there. Is this an inverse function? Yes or no? I'm going to say no. Why? It fails the vertical line test. Fails vertical line test. We're going to make it short. VLT. Okay? Name 3 coordinates. Let's try another one. Let's name 3 coordinates from the point below. How about negative 3, 0? About right here. About negative 1, 2. And 1, 4. Alright. Negative 3, 0. Remember, if I'm moving too fast, pause it, slow down, catch yourself up. Alright. Now let's name 3 inverses. So we just flip them. 0, negative 3 now. 2, negative 1. 4, 1. And let's plot those points. 0, negative 3. There's 1. 2, negative 1. There's 1. 4, 1. Boom. Alright, so this is going to look like something like that. Okay, not the prettiest. So, is it a function? Passes a vertical line test in my book, so I'd say yes. Passes vertical line test. Alright, so what the horizontal line test is, it's the shortcut for the vertical line test on inverse. So again, if I draw, these all pass if I draw a horizontal line and they pass the horizontal line test, they're gonna pass the vertical line test as well when we do the inverse. Okay, so this one's inverse is a function, right? Because it passes here, boom, passes there and there. So this one does have an inverse, and you could draw the inverse if you wanted to, but since it passes both times, its inverse is going to be a function. Now these fail the horizontal line test, and the function that is an inverse of it is not going to be a function. Like this one, boom, here, hits twice, because when we graph it, if we did the inverse, it's going to look something like that, and it's going to fail anyway. Okay, so that's just a shortcut. All right, what do we got? Whoa, don't write there. All right, so I'm going to give you a second or a minute. I'm going to say go ahead and pause this and try these problems, these practice problems. So we got, what, 2 practice problems? I want you to pause for a second and try them. All right, so hopefully you tried them. If not, I'm gonna go over these in 3 seconds. All right. Okay, so name 3 points on here. So we're gonna go right here, and where else does it cross? Right there. So that's negative 1, 0, 1, 3, and 2, 2. All right, name the 3 inverse coordinate points. So 0, negative 1, 3, 1, 2, 2. Now we can already tell by the horizontal line test that the inverse is not going to be a function. This one right here, this graph that's already shown, is in fact a function. Okay, but it's inverse, not a function. But let's just go ahead and try it. So 0, negative 1. So 0, negative 1, 3, 1, 2, 2, right there. Okay, what did I mess up? Oh, 3, 1, 1, 3. There we go. 1, 3, 3, 1, 2, 2. Zero, negative 1. What did I do? 0, negative 1, 3, 1, and 2, 2. Interesting. Oh, goes the other way. Oops. I was thinking it went. So I'm like, that doesn't look right. It goes this way. Okay. So what that does, is it a function? Nope. Fails HLT and BLT consequently. Let's try one more, final one here. All right, so name some points. Got negative 3, 2. 3, 0. 0, 3. And 3, 4. All right, let's do the inverses. 2, negative 3. 3, 0. And 4, 3. All right, So, is this a function? Oh, I guess we got to graph it first, right? 2, -3, 3, 0, 4, 3. Yes, it's a function because it passes HLT and VLT. All right, guys, so that's it for the notes. Go ahead and do the mini reflection. When do you use the vertical line test? When do you use the horizontal line test? Now, what you're going to do once you're done with these notes, make sure you're taking a screenshot of them and sending them in on using Schoology. Okay, use a screenshot, take a picture of them, upload them, whatever, just so I know you guys did this. And then go ahead in the next section of Schoology and you are going to do the Khan Academy / Delta Math assessment for today. All right, and you will get that back on Monday. All right, guys, if you have any questions, please come to Math Lab on Monday. I'll be there from 3 to 4 o'clock, and would math help? All right, have a good one.